I made 3 videos on interconversions of the organic chemistry of junior inter concerned. There are some left behind points. So this video finishes about the complete idea of the junior inter organic chemistry. Conversions 4. Three moles of acetylene on heating in red hot tube, which is also named as a trimerization. It produces benzene, which is an aromatic compound. This benzene has characteristic property electrophilic substitution. It is a characteristic property. So Cl2 in presence of anhydrous AlCl3, it produces chlorobenzene and a byproduct HCl. I already told you we are not concerned with the byproducts HCl, chlorobenzene. This chlorobenzene, chlorine is attached to sp2 carbon, so less reactive. Therefore, this is to be heated with KOH in presence of high pressure. Then the Cl will be replaced. Otherwise, there is no chance of Cl replacing it. It produces phenol. At ordinary condition, there is no question of reaction. This is aqueous KOH. Now, this phenol reacts with the zinc dust. Zinc is a good reducing agent. It reduces phenol into benzene back. Now, this benzene reacts with propyl chloride in presence of anhydrous AlCl3. It produces this compound, isopropyl benzene. This is the main product, isopropyl benzene. N-propyl benzene is also there, but isopropyl benzene is the main product. This is also named as cumene. This isopropyl benzene reacts with oxygen in presence of air. It produces, that means it readily undergoes oxidation like this. It produces CH3, COH. This is a tertiary hydrogen. This is alkane type. This is a tertiary hydrogen. This tertiary hydrogen is oxidized by potassium permanganate also. Even with mild that is oxidizing agents, this is even with oxygen it undergoes oxidation because this hydrogen is active when compared to alkanes. Because in alkanes this carbon is attached to sp3. Here it is attached to sp3 and sp2. In case of alkanes do not react with oxygen. But here, this cumene reacts with oxygen. Why? Because sp2 carbon is attached to this carbon. Therefore, this is highly active. Likewise, it forms cumene peroxide. This is called cumene peroxide. This cumene peroxide or hydrolysis, it produces two compounds. Cumene peroxide anhydrous produces two compounds, phenol plus acetone. This acetone, I'm not discussing about this. This acetone reacts with zinc amalgam and concentrated HCl. This is the best reducing agent known as Clemmensen reduction. This Clemmensen reduction produces acetone into propane. Propane is an alkane. The characteristic property of alkane is free radical substitution. It undergoes nitration, sulfonation, halogenation, but we are much concerned to the halogenation. This reacts with Cl2 in UV light. It produces this compound, that is CH3, CHCl, CH3. Isopropyl chloride is the major product. And this reacts with aqueous silver oxide. It produces silver hydroxide. Aqueous base and replaces this. And it forms CH3, CHOH, CH3, isopropyl alcohol. This on heating with the acids, it undergoes elimination, dehydration. It produces CH3, CH2, double bond CH2. This is a propene. This propene reacts with the concentrated sulfuric acid. Characteristic property of alkene is electrophilic addition. Here I have added concentrated sulfuric acid. Concentrated sulfuric acid causes Markovnikov addition because of unsymmetrical alkene. This Markovnikov addition, CH3, it changes into like this. HSO4 and CH3. Negative part adds to this compound on hydrolysis, addition with water, produce propyl alcohol. Or you can read like this. Propene with dilute sulfuric acid. This is concentrated sulfuric acid followed by addition. It is nothing but dilute sulfuric acid. You may write like this. Concentrated sulfuric acid, this dilute sulfuric acid is this. After the addition, water is added and it forms isopropyl alcohol. This isopropyl alcohol on reaction with phosphorus and chlorine. Phosphorus and chlorine reacts PCl3, PCl5 likewise. So here it forms CH3, CHCl, isopropyl chloride. This reacts with ethyl alcohol and KOH. This is called alcoholic KOH. It produces CH3, CH double bond CH2. That is once again propene. Now, propene on reaction with the base reagent, that is KMnO4 in presence of base at 25 degrees centigrade. It produces CH3, CHOH, CH2OH, glycols. This is called glycols. These glycols on reaction with PCl3 or PCl5 change into CH3, CHCl, CH2Cl. That means OH is replaced by Cl. This is the repeated concept here. And this on heating with alcoholic OH, and upon strong heating, it produces CH3, CH, or rather C triple bond CH propyne. If this is not sufficient, it can be used like this, sodamide. First, alcoholic OH is used for dehydrohalogenous HCl is eliminated. If that is not sufficient, this is a powerful reagent. It eliminates HCl once again. It produces propyne. This propyne on hydrogenation in presence of sodamide. It is a partial hydrogenation, produces CH3, CH double bond CH2, propene on ozonolysis in presence of zinc and water, double bond breaks here. It produces CH3, CHO. This is the major product, plus formaldehyde. I'm speaking about this acetaldehyde. On oxidation, acetic acid is produced. Acetic acid on reaction with potassium metal, it produces CH3COOK. Potassium acetate. This potassium acetate on coal-based electrolysis, it produces CH3 at anode. Ethane is formed at anode, carbon dioxide is formed at anode, potassium hydroxide at cathode, and hydrogen. Now this ethane, upon heating to 450 degrees centigrade, ethylene is obtained. Ethylene reacts with Cl2 to form ethylene. This one reacts with excess benzene in presence of anhydrous AlCl3 Benzene characteristic property is electrophilic substitution. It produces this compound. This is the compound.